In this lab, I'm going to show you how to read a routing table. And the purpose of a routing table is to list all the routes to a specific destination and the next hop address for packet forwarding. And the next hop address is just the next hop neighbor IP address and the local exit interface to reach that neighbor. There are also routes that are only associated with a local exit interface. So any network is comprised of multiple subnets. So what I've got here on the left here, I've got this layer 2 switch. And host 1 and host 2 are in the same subnet. So they're associated with the same VLAN. And here it's a VLAN 10. So 192.168.1, that's a single subnet. And that also includes the default gateway interface gig 002 on R1. So they're all in the same subnet. So that's subnet number 1. You also have these WAN links, and they have their own separate subnets. Each router interface is a separate broadcast domain, and it's got its own subnet. However, the broadcast domain is only a single interface. And that contrasts with a layer 2 switch where you have larger broadcast domains, since you can have multiple hosts connected to a switch that are assigned to the same VLAN. So you've got multiple switch interfaces assigned to the same VLAN. And that creates a larger broadcast domain, since every VLAN is a broadcast domain. So here on R1, there's actually 3 broadcast domains, since there's 3 separate interfaces. So the link between R1 and R2 is the 192.168.3 subnet. The link between R1 and R3, that's the 192.168.2 subnet. And finally, there's R3 to R2 link, and that's 192.168.4 subnet. And R2 as well has 3 interfaces just like R1. There's this link between R2 and the layer 3 switch, and that's 172.16.1 subnet. Then each of these 3 servers are in their own subnet. The HTTP server's got 172.16.2 subnet. And typically you'd have multiple servers in the same subnet. But here, this is a basic topology. I'm only showing one server. Then there's also the DNS server. That's 172.16.3 subnet. And the FTP server, that's in the 172.16.4 subnet. So they're all assigned to their own subnet on that layer 3 switch. So what I've got is multiple subnets here. So I'm going to go to R1 and look at the routing table. We'll select CLI. The command is show IP route. So there's my routing table. See at the top here, it's got the codes that list what type of route source it is. Here the O stands for OSPF, and connected routes are just the connected interfaces on the local router. And I don't have any static routes, so it's all OSPF. You can see here, you can match up static as S and ERGRP as D and some other ones as well. So what Cisco does is they'll list these subnets in order based on the number. So the lower numbers go first. 172 would show first, then 192 would show after that. If you had something like 200 subnets, that would show at the bottom. So at the top there's 172.16 subnet, and below that I've got 172.16.1, 1, 2, 3, and 4. So that's being advertised over from the data center. So there it is here. So R1's learned these from the layer 3 switch that advertised them to R2, and R2 advertised them to R1. So R1's going to send the packets to R2, since it's the most direct link to send packets to any of these servers. You've got 172.16.1, 1, 2, 3, and 4. The link between R1 and R3 is only a backup link, since that's going to require an extra hop and will be a higher cost. So based on OSPF, we would just select a more direct route to R2. So there it is. They receive via 192.168.3.2. The exit interface is gig 001. So there's the exit interface, gig 001. 3.2 is this interface, gig 001 on R2. So that all makes sense. That is working correctly. Then the next one is just the connected route, 192.168.1.0. And the 192.168.1.254, that's actually the host route, and that's the default gateway. That's gig 002. So that just says this is all connected. This is 192.168.1 subnet, and that's directly connected. So that's correct. Then the 192.168.2 and 192.168.3, those are the WAN links, and also 192.168.4, 192.168.2 and 192.168.3. And they're listed as connected routes since they are directly connected. The 192.168.4.0 was not directly connected. From R1, that's the link between R3 and R2. And it has two routes to get there that are equal cost. So we can go via R3 or via R2. And that's an OSPF route. You can see there's two routes that are listed via 192.168.2 or 3.2. And it shows the local exit interface as well, 000 or 001. And finally, there's some loopbacks at the bottom here. The loopback configured on R1 is 192.168.2.551/32. That's a host route. It's C for connected since it's local to R1. The 192.168.2.552, 3, and 4. These are all in the same subnet, but they're on different routers, and they're just being advertised via OSPF. They're configured on R2, R3, and the layer 3 switch. So going through, you can see how the routes are listed and how this next hop address is pretty key to getting the packets to their destination. And it's all per hop routing. So when the packets arrive at R2, then R2 will do a lookup again for, say, 172.16.2. And the layer 3 switch will have advertised that route to R2, so it says send it to me because this is directly connected subnet. That's how packets get to their destination. And that concludes the lab.